Hello everyone, I'm Alekos Caporali and I'm graphics technical artist for the demo team at Imagination Technologies. The purpose of today's session is to show you the advancements made by Imagination and O3DE in getting ray tracing on your devices, both for developers and artists and gamers. We made big progress towards achieving ray tracing on mobile especially, so during the presentation I will showcase how powerful ray tracing is in terms of the visual enhancements that it can provide in a mobile-friendly game environment, and I will demonstrate how easy it is to implement some of its features in O3D from the artist's point of view. But first, let me give you a bit of context for anyone that might not be familiar with both Imagination and O3D before we get into it. So Imagination Technologies has been designing GPUs among other things, for the past 30 years. We are a UK-based company, and our technology has ranged from mobile devices to desktop and consoles to automotive and other applications. For the old school gamers out there, you might remember us for one of my favorite consoles of all time, which is the Sega Dreamcast, and we are so proud of that we printed it on the back of our hoodie. And the console came out at the end of the 1990s. I was quite young, but I still loved it. By the way, all this experience has given us the opportunity to pioneer hardware ray tracing research since 2007. And today we are leaders in the mobile GPU space and in mobile hardware ray tracing. But not all ray tracing hardware is the same. And there are several points to consider when you get to evaluate the performances of different solutions. That's why, in order to help identify the different levels of ray tracing capabilities in modern hardware, we've come up with a chart. The key point of the chart is that as we go up each level, there is an increased focus on efficiency. The market, however, does not always move based on efficiency. So, for example, the recently released second generation of ray tracing capable desktop PC hardware has increased the performances by simply providing more ray tracing processing, which naturally requires more silicon area and then more power. However, this brute force approach is not a viable option for solutions that need to operate within a power budget like mobile. And I'm not going through all the levels shown here. What you need, not going through in detail about all the levels shown here. What you need to know is that level 0 and 1 are older solutions that are rarely seen anymore, and they were the solution that kick-started ray tracing. Level 2 and 3 are the most popular types of ray tracing being used nowadays. And finally, and these are the two levels that we will concentrate on today, there is level 4, which is the bounding volume hierarchy processing with coherency sorting in hardware, which is the best implementation of hardware mobile ray tracing at the present time, and it's the hardware ray tracing in Imagination GPUs. Level 5 is an even more advanced system developed by Imagination Technologies and demonstrated in 2016 with the GR6500 test board, where also the BVH processing is sorted with a dedicated hardware solution, and it's even more efficient. To summarize, with these last two levels that I just described, level 4 and 5, Imagination Technologies developed a system that increases the efficiency of ray tracing based on the way that rays that have a coherent bouncing angle on a surface are sorted together, hence the name coherency sorting. And this technology is allowing less stress on the hardware, and which makes it very suitable, especially for mobile solutions. Obviously, these kind of features, hardware advancements, needs proper software in support. So in the next slide, let's also talk about O3DE and what it has to offer to gamers and developers like us. So let's get to the engine that made some of this ray tracing implementation possible. O3D engine, O3D in short, is a game engine that, as part of the name states, it's open source and it's free. Some of its main benefits are that the engine is completely modular and it's also cross-platform, making it very versatile for developers. And getting to our part of the story, we got to know O3D last year in 2021, where the engine was just a newborn and many of its features were presented for the first time. We got really interested in it for what it had to offer and for its open source nature. So we decided to start testing it, discovering its features and eventually its potential, and up to the point that we decided to make graphics demos with it to showcase Ray-Traced Global Illumination. At the beginning, it wasn't really easy. Like as everything new you may stumble upon in life, we needed to familiarize with the editor a little bit, and some of the features needed adjustments. But I must say that in this 1 year time span, the engine made giant leaps thanks to the great effort that the community and the developers have put into it. So nowadays, in Imagination, we use the engine not only to showcase ray tracing features like GI to game studios, but also we benefit a lot from it just by visualizing some of our assets and demos in game playback. And now, after giving you a little bit of introduction about O3D and what we do at Imagination Technologies, here's the agenda for the remainder of the session. I split the presentation in 2 parts. I'll firstly talk about the things that you need to know and learn about Ray-Traced Global Illumination and O3DE. So we'll speak about the difference between GI and RTGI. Then I will showcase the graphics demo that we made at Imagination Technologies about RTGI, so you can see what the system allows to achieve visually. And finally, I will give you some useful tips before jumping right into the engine. Then, in the second part, I will demonstrate how to get acquainted to some of the O3D basic features and teach you how to implement real-time ray-traced global illumination in the engine, step by step. Also, I will talk a little bit about what awaits for 3D and ray tracing in the future. So, if we are ready, and I bet you are, let's dive into the first section. The first thing that I want to talk about is the difference between global illumination and ray-traced global illumination. For those of you who are not familiar with global illumination, GI is a system that models how light bounces and diffuses from surfaces onto other surfaces using indirect light or secondary light bounces, rather than being limited to just the light that hits a surface straight from the light source. So as you can see in the image here, the light that is bouncing off the red and the blue wall is diffused to the spheres next to it, so that they get partially tinted with the color of the secondary light bounce. I must specify that global illumination is not a new system in game engines, but the problem with that is that when it's used as a baked instance, as a baked system, you cannot move or change your objects and lighting in the scene because these changes will not affect the system at all. And that's where ray tracing comes to help. With RTGI, which stands for Ray-Traced Global Illumination, the system becomes completely dynamic and adaptive, updating every time something changes or moves in the scene. As you can see in the video playing, every time that you change a material, you will see that, for example, I will grab a green material, the diffusion from the wall changes from blue to green. And again, if I take a yellow material, the diffusion changes from green to yellow, and it adapts in real time. Okay, now you know what RTGI is capable of doing, so why don't we have a look at the graphics demo that we made in O3D and that showcases some of these ray tracing global illumination features. The video that I'm going to play is available online and on our YouTube channel, so feel free to get there if you want to have another look at it afterwards. But first, let's watch it together. By the way, this demo was called Buongiorno, and it's one of the most recent graphics demo that about ray tracing implementations that we made and developed at Imagination Technologies. It is essentially a stylized representation of an Italian-like village, which main purpose is to showcase how global illumination works in real time using ray tracing. Jumping to the feature description, and you will be able to see them on the video recorded in the O3DE viewport that I'm going to show in a moment. The main ways RTGI helps enhancing the environment lighting are essentially two. The first one is that it diffuses the material colors to the surrounding geometry in real time, also when materials and objects changes or move inside the scene. So you will see this happening when the material changes, the color that gets diffused from the building on the left changes depending on the material that is going to be applied to the walls. On top of that, it helps the local light condition to appear more natural depending on how much light is bouncing around from the surrounding objects. So as you will see in the video, the light is bouncing on the building on the left, but where the cloud is passing by and it's preventing the light to bounce on this building, also the rest of the environment is getting darker in real time. RTGI is one of the easiest ray tracing implementations in game engines, and also one of the less intensive in terms of ray usage. But as you could see in the demo and here in the video, it provides a big step up in the general look of mobile video games, especially. Let's now jump into the next slide, where I want to give you a little bit more context and details about how the feature works. Something that we need to get familiar with before getting to know how to manually set and activate the feature is understanding what really ray-traced global illumination is and how it works both in real life and in the engine. It's important to mention that RTGI's purpose is to reproduce a real-life physical phenomenon where the light bouncing from an object is naturally and dynamically diffused to other objects in the nearbys. So with a simple demonstration video, I can show you how it works in the real world. You will be able to see that if I take my phone torch and I aim it straight to a blue object, for example, the light that gets diffused from that object is colored with a blue tint. On the other side, when I use a red object, the diffused light is colored with a red tint. So you can have another look at the feature taking place in real life again, and the difference between the first and the second object. But now, how does O3D tries to achieve the same result in the software using ray tracing? Well, it uses diffusion probes. So the scene is filled with a grid of probes, and ray tracing casts hundreds of rays around each probe. Probes detect where the rays intersect with the nearby geometry, and starting from this information, they project back an irradiance texture to the geometry itself, spreading light intensity and color. This happens whole across the scene, where the probes activates and deactivates in real time, depending on where the active geometry is. And thanks to this behavior, the feature is really well optimized, and this is one of the main benefits that it has to offer. In the next slide, I want to talk about which are the other benefits, and I will give you some tips before getting in O3D and implementing the feature together. O3D RTGI has many pros, as I was mentioning, so I will start from there. First of all, it has to offer many benefits for the game or the graphics demo itself. So it's a graphic enhancer, which means that improves the realism of the environment lighting in the entire scene. Then it is able to take into account more than one light source at a time. And finally, it's very cheap for ray tracing, which means that it doesn't impact your hardware performances. But it doesn't have only benefits for the graphic demo or the game. It also has benefits for artists and developers. So with real-time global illumination, you will be able to control your environment lighting in real time. So every modification on the scene assets, you will see that it will update the feature in real time. And it's also really easy to implement and to repeat around and to tweak. So just a few clicks allows to implement the feature, or more than one if you need that. And also, it doesn't have so many complex parameters to deal with. So it's very simple to implement and to tweak. OK, now we are finally ready to jump in the next section, which is going to be about the best practices. First of all, I want to talk about knowing your PC and your target hardware specs. With that, I mean that if you're developing on a PC that is not provided with ray tracing, you will not be able, obviously, to see ray-traced global illumination taking place in the scene. And same, if you want to implement ray-traced global illumination, also your device where the demo or the video game is going to play needs to be provided with ray tracing cores. So this is the first thing to be careful of. Second, you need to know your assets and your materials. With that, I mean that obviously ray tracing depends on the complexity of the scene and so how many polygons you have in the scene. This means that you will need to implement a good workflow for your assets, optimized workflow for your assets if you need, especially depending on how much geometry you will have in the scene. You will need to have a balance of that. Also, you will need to be careful about how you project your normal maps and how you assign your edges, the hardness of your edges on the mesh. So these are general tips, but they help. Also, finally, getting to the materials, you will need to know that O3DE applies the diffusion depending on the irradiance value that is applied to the material. So if you will need an object to spread 2 different colors, you will need to split these materials because every material diffuses a different color. So you will be able to see that if I take three of the PBR materials in O3DE, all of them has the same value, which is called irradiance, that you will be able to set and you will find at the bottom of your material editor in the settings. From here, you will be able to set the color and the intensity for the irradiance value, which defines the color and the value of the color that gets diffused from the material itself. OK, this is all that you needed to know. So we are finally ready to jump in the engine and finally implement ray tracing together, ray-traced global illumination together. So let's get into it. This second section of the workshop is going to be dedicated to get you acquainted to some of O3DE basic features, so you can learn from scratch how to create a scene, implement some assets, lights, materials, and finally real-time global illumination. We will go through that together step by step. So let's dive into that. The very first thing that we need to do together is obviously choosing your O3DE version, and you will find them on the download section of the O3DE website. You can decide between 2 versions, so you have the stable build or the nightly development build. The differences between the 2 is that obviously the stable build contains more stable features. But if you are like me and you like to discover new features and new implementations that the developers are working on at the moment, you may want to go for the nightly development build with the con that you may find some bugs maybe in some of the features, but this is because they are still being implemented. By the way, once you decide which version to go for, now it's time for you to install the engine. And the first page you will stumble upon once you click on the O3DE icon will be the project manager. The name is quite self-explanatory. So from here, you will be able to create, add, or edit your projects. If you drag your mouse to the top right side of the editor, you will be able to see the different options. And for the sake of the presentation, I will create a new project from scratch for today's demonstration. So once you click on create the project, the project manager brings you to the project creation page, where you can set the name of the project and the location of the project on your PC. And obviously, you will be able to set other things, like, for example, on the bottom right of the screen, you will see that you have a button for setting new gems. But what are gems? Gems are the system of add-ons that makes O3DE completely modular. In fact, you will be able to get back at any time to the project manager and add or remove gems in order to apply or implement new features. And also, we will go on and activate couple features couple gems for the sake of our demonstration. So I will look for global illumination, and you will see that there is a gem which is called diffuse probe grid, and I will activate that. But also for later, I will activate another gem, but this is a little bit of a spoiler. So I will click on Create Project, and now you will be brought to the page where you can create your project. Where the project is being created, you can assign a thumbnail, and then you will need just to build the project, and finally open the project and jump in the engine. So we are finally ready to be brought to the main editor page, and here starts the real implementation. The first window that you will see in the editor, it's an empty window, obviously, so you will need to go to File and create a new scene. I will rename it RTGI level, and click OK. You will see that on the scene you will have different assets that are embedded in the new scene, and I will get rid of some of them because I want an empty scene and I want to implement all of the assets with you to get through also like the basic features of the engine, and I will deactivate the IBL, which is the image-based lighting that determines the HDRI and some of the other lighting. I will deactivate it for now, so we have an empty scene. Next thing I want to do is implement some assets. So how to import and implement the models. It's important to do. You can right-click on the viewport, and you will be able to create a new entity. Entities are containers for everything that you want to create in O3DE, so you will need to assign components to them. So if you click on Add New Components, I will look for the mesh component, and I will add a mesh component indeed. From here, you can select one, clicking on the small folder on the right, you will be able to select one of the entities that are, or one of the models that are embedded in the O3DE project, and I will go for a cube. Starting from this cube, I want to create a sort of a room, so I want to add a new couple components for managing the scale a little bit better, and I will go for something like, I want to create something like walls, so I will start to move them around and place them a little bit better using a mix of the gizmos and of the transformation component that allows you to manage the transformation manually by setting the values with numbers. By the way, I will do that. I will start duplicating the objects that you can do with Ctrl-D and just moving them around, creating the other walls that will build up the room, and go on again, placing them a little bit better, rotate them, and up to the point that we will have sort of 5 walls that determines the boundaries of our room. OK. Looks fine. Pretty much looks like a room, except we don't have the front wall because we want to look inside of it, except that we cannot look inside of it because we don't have a light. So for now, let's make some organization, and let's tidy up the project a little bit. So I will create a new entity which will be the container, sort of like a folder for the other entities that I just created. I will rename it walls, and I will put all my walls inside that. So the project will be a little bit more organized, and then I will rename a couple of the assets. So for example, the floor and the walls are OK, I think, and also I will rename the ceiling. And right now, the project is already looking a little bit more tidy for our purpose. After that, obviously, we will need to implement some lighting. And if we want to implement lights, it's the same process, more or less. So you will need to go in the viewport, and you can click. You can create a new entity, and I will rename it point light, because it's going to be a point light, obviously. Remember to set the the position of your object to be at 0, 0, 0, so at the origin of the word every time, so you will be able to find it and move it a little bit better. But by the way, to this component, I just added a new light component, and you will see that you have different options for the different kind of lights that you may want to apply, and I will go for a point light, a simple point light, and starting moving that in the scene so it's placed in the middle of the room. Okay, so with the gizmo it's a little bit difficult, especially if you don't want to move the camera around, but yeah, with the transformation component, you can easily do that. And let's move it inside the Atom default environment, all still for the sake of organization. Okay, now we have walls, we have lights, and we will need to create materials to apply to this object, to these walls. So how to create material is really simple. You will have a separate editor, which icon I will show here. It's on the top of your viewport. So clicking on this will open a new editor, which is the material editor. Indeed, it's the editor where you can manage, create, and edit your materials. And from here, I can go in the subfolder from the asset browser. I can go in subfolders. I already created a subfolder for materials. So I will right-click on that and create a new material. I will go for, you have different options, but I will go for standard PBR material for today. And also, I will specify the name of the material, which will be one of the walls material, and it will be a red material. So. Okay, we have the main material set, and we can have a look at what it has to offer. So it has all the things that you're used to, so base color, roughness values, metallic values, so you can assign textures. Also has the irradiance value that you can set manually, or you can set taking the color from the texture itself, from the base color texture itself. Since it's going to be a red material, I will go for a red color selection, and also, I will not apply any other texture. What I will do is going for a manual implementation of the color of the irradiance. And simply by copy and pasting the value of the RGB values, I can get there and get a red diffusion from the material itself. So this is enough for the sake of the demonstration, and I will save the material. What we need to do next is creating new materials, obviously, in support of the project. So I will go on and create maybe a couple more or 3 more so that we can see also the differences later when we want to change them. So I want to create a green material now, and I will go in the color picker and select a green color, click OK, and as I did before, just copying the values, the RGB values, and pasting them to the irradiance values, keeping the factor at 1 because I want all the color to spread. So, okay, save that and create another material, which is going to be a blue material. So again, same process. Yeah, I know it's a little bit mechanical, but we need to do that. So let's select a blue color for this. Just click OK, and as we did before, just copying the value, the RGB value, and paste it to the irradiance value. I think we can save the material, first of all, which is very important. I think we are all set with the colored material. So what we can do next actually is creating the last one, I promise. It's going to be a white material for the rest of the objects, because also we want the white objects to spread some light intensity. So we will need to create a white material as well. And you will see the difference with that. Obviously, it already has the white color assigned to it, but I will not go for full intensity of the light spreading. I will go for something like 0.5. And yeah, I can save it, and we are all done in the material editor for the demonstration today. So let's close it. Okay, we created new materials, and now we need to assign them. So if we go to if I select the floor, you will see that on the mesh component, you will see a button with create new material. From here, you will be able to go on your folders, on your asset browser, and select one of the materials that we just created. So I'll select the white material for the floor, and instead for the left wall, I will select something different, like a red material. And let's assign it. For the right wall, I will go for the blue material for now. And for the rest of the walls and the ceiling, I will go for the white material as well. OK, we are all done with the material implementations. And what we need to do next is maybe cleaning the viewport a little bit. So what I will do is going up in the small eye icon and deactivate the icons so we have a cleaner view of the room that we just created. Then, OK, we can start creating the spheres and the other objects that will be getting the light diffused from the walls. So I'm going to create new objects, new entities. And let's click on the viewport, right-click on the viewport, create a new entity. And I will rename it spheres, because this will be the folder for the other entities that I will create inside. Let's place it in the origin of the world again. And you can right-click on this new entity, and you will have new entities, new sub-entities created internally automatically. So I will create my first sphere and assign a new mesh component to it. This time, instead of going for a box like I did for the walls, I will go for a sphere. It's one of the embedded models that you have in O3DE. And I will assign a new material for it, the white material that we created previously. And we can just move it around in the scene and place it a little bit better using, again, a mix of the gizmos and the component, the translation component, transformation component. So let's place it a little bit better in the room. And let's duplicate it and rename it Sphere 2, move it to the other side of the room. And actually, we are all set to finally start implementing Ray-Traced Global Illumination. OK, last thing that I want to show you before getting to implement the components for the Ray-Traced Global Illumination is going to your light setting and showing that if I increase the light, you will see no secondary lights diffused from the walls, which is supposed to happen only when you implement global illumination or better ray-traced global illumination. So let's set a higher value for the light, like 230 should be good. And OK, we are all set to start implementing the RTGI components. The first component that we need to enable is the diffuse GI component, and you will find it in the level section. So if you go to your level, you can look for diffuse global illumination, and you will be able to set the quality of the feature straight away. But obviously, you are still not able to see that, so I will go for medium for now. And then, after you did that, you will need to apply another component to create another component, which is the diffuse probe grid component. So you will need to create a new entity again. And this will be the container for the RTGI. So I will rename it RTGI and place it to the origin of the world again. Maybe let's move it inside the Atom default environment so we have a little bit more organization. And I will be able to look for the diffuse probe grid component, which is the one that defines the boundaries where the probes are distributed in. But as you can see, this component requires a new component. So it will ask you to create a box component to determine the boundaries of the global illumination system. So if I activate, the overrides, you will be able to see the boundaries of the box. And right now, you will be able to set some bounding boxes which are a little bit more, a little bit better for the room that we created. So right now, I just did it. It's just a few clicks, and you can deactivate the box overlay again, and you will be able to see that some of the feature is already taking place in the scene. We need now to get a little bit more in depth about the implementation itself. So if you go to RTGI, to the entity that we just created, we will see different things that we can tweak. The probe spacing is obviously the spacing between the probes. And then you have some ambient multiply, you have your biases, you have the number of rays for each probe. So that goes from 144 to 1000. Then you can set your feature to be baked or real-time or automatic, depending on your hardware. So O3DE will detect that, and you can do that both in viewport and in play mode. Finally, you can activate the visualization of the probes. So we need artists to implement this kind of feature, and we can start activating the probes and starting distributing them a little bit better. So I will go for something like 0.8 spacing, so you will be able to see them a little bit better. I will decrease how big the probes are in the scene, and I will place the global illumination system a little bit better, so it fits the room a little bit better. Okay, we can start seeing the global illumination taking place a little bit better. That's fine. And you will see some of the light that gets detected by the probes on the side. So we can also activate the inactive probes, so you will be able to see that some of them are inactive depending on where the geometry is. So let's deactivate the visualization of the probes. And yeah, you will see that actually the feature looks a little bit better. So if I deactivate it and reactivate it, you can see clearly that some of the color from the walls is spread to the other objects in the surroundings. What we need to do next is going a little bit more in setting the features a little bit better. So for the intensity, for the multiply intensity, usually I like to stay at 1 because it's a good practice. But for the biases, it's up to you, depending on how the probes are distributed inside the scene. So going for high values usually creates some kind of artifacts. So I like to keep the biases values to something like 0.1. You can see some artifacts getting up if you increase the values. So I will go for 0.1 and 0.1. Also, I will change the spacing of the probes so they fit a little bit better to fix some other small artifacts that I had on the ceilings. So it's a kind of artistic process. You need an artist to implement that. I can go for 144 rays, but also 1000 rays. It's quite a small scene, so both of them will work, but I will go for 144 to have the feature optimized. And again, I recall you that you can go back and forth on your level to set the quality of the system itself. So I will go for high for now, just for the sake of the demonstration. And yeah, what we can start doing is, again, making sure that the feature is activated with RTGI if you are provided of ray tracing on your desktop. And also you will have other settings that you can play with, especially if you want your objects to move inside the scene. Something else that we can play with at the moment, we have the feature implemented, so we can start moving the lights around and see that the feature is taking place. So if I move the light next to the red wall, you will see more red diffusion. If I move it next to the blue wall, you will see a little bit of blue diffusion. And yeah, I will replace it in the center of the room. Also, I can increase and decrease the value, the intensity of the light, and you will see that the GI system is reacting in real time to these changes. Another thing that I can do is selecting the objects and moving them around. So if they are far away from the wall or next to the wall, the intensity will vary. So for this sphere, if I move it to the other side of the room, you will see that it will get the diffusion from the other wall in real time, depending on how far from the wall it is. And finally, as I showcased before, you can also change materials in real time. So if I pick another material like the green material, you will see that the diffusion, the bouncing light from the wall, will affect the light that gets diffused to the spheres. So if I select a red wall, you will see a red diffusion. If I select a white material, you will see that you only have light diffusion, which is another option. And let's get back to the blue material that we created initially. OK, this is how you implement real-time global illumination. What we can do next is maybe activating a couple more things, like shadows for the light that you cannot see here. So you can activate them from the light settings, and you can choose between different kind of filterings. I will not go like in detail about that, but also I want you to notice what happens when I move the spheres around slowly. So you will see maybe some artifacts taking place. It depends from the fact that the global illumination system is detecting how the object moves inside the probe grid, but sometimes it struggles to detect like the precise point to detect it from one probe or the other. So we can create other subsystems attached to the spheres that will move together with the spheres. And the different system, the general system, and these subsystems will work together. So we will be able to see the probes that are distributed for this subsystem. And I can go for some bounding boxes which are a little bit better for the spheres themselves. And obviously, you can see that some of the probes are inactive. Right now, if I take my sphere with the GI subsystem, and if I move it around, you will see that the light it still has some artifacts, so it's up to you to get there and fix it a little bit better. But you will see that moving the object around doesn't create like the splotchiness from the probes that we were seeing before. So let's just duplicate this asset and move it to the other side of the scene. And I think we are all done for the implementation in this kind of test scene. So perfect. That's how you implement basic models, materials, lights, and RTGI systems to start visualizing the secondary light bounces diffusion in your video games or graphic demo within a simple level. But where do we go from now on? As I mentioned at the start of my presentation, we have some good other stuff for you related to RTGI. And specifically, we made our assets that I showcased in the demo to be open source, so you can access them freely and use them for your testing of the feature. You will be able to access them by copying the Buongiorno gem that contains them, copying it from the O3DE repository on GitHub, and then registering the gem to either the engine or a specific project. You will just need to follow the instruction on the guide that you will find on GitHub, on the GitHub repository, or in the README file inside the gem after you downloaded it. Then, after having this done, you will be able to go through your project settings in the project manager, and again, clicking on Add More Gems, you will be able, as I showcased before, you will be able to look for global illumination and see the Buongiorno assets demo that is here, and it's waiting for you to be activated. So this one. OK, we can apply the changes that we made, the gems that we enabled. And what you will need to do is recreate the scene and rebuild it. Next, I will showcase how some of these assets look. So it's quite easy to implement them. I will change the right wall that I created before with something else, like a Vespa. So let's take this Vespa and let's change the scale settings, reset it to 1:1:1, and just move it a little bit better so it's more next to the floor. Zooming out a little bit. And For this entity, this mesh, I will need to create and reassign a new material, which is, again, in the asset that we made open source. So you will be able to select that as well, looking for Vespa material. Same for the wall on the left. I will change it with something else, like a Beetle car. And let's get the scale to something like 2.3. I think it will work. And let's move it to more near to the floor. I will move also like the spheres around a little bit, so we will be able to see some of the global illumination taking place a little bit better. And what we need to do next is assign, obviously, a material to this beetle, and you will find it embedded in the gem. So, OK, now we have it set. We can deactivate some of the walls that we are not using, like the ceiling and the back wall. And we will be able to set a different scale for the floor. So it's a little bit better for the demonstration. Let's move the spheres. And now let's activate back the IBL and the directional light. So you will be able to see if I move a little bit closer to the objects, you will be able to see that some of the light from the materials is getting spread to the spheres that I created before. OK, what we need to do next, obviously, so this scene is still using the old RTGI system that I created for the other room. So we will need to set something better. First of all, let's deactivate the subsystems for the spheres that I created before. We don't need them anymore. And let's do something. Let's increase the bounding boxes of the RTGI so they contain the 2 new objects that I created. I will even go a little bit overshoot it for them. But you will be able to see that since the feature is very optimized, if I activate the probes, you will see that the probes are active only where the active geometry is. So they will adapt in real time. And most of the probes that are in the cage are not active, and they're not like influencing they're not like impacting the performances of the demo. So this is how you implement global illumination, and this is how you can use some of our open source assets. But not only that, we will share still you can get on the O3DE GitHub repository, and you will be able to download our scene, the scene that we made for the Buongiorno demo that I showcased before. So you will need to download it and assign the project. Instead of creating a new project, you will need to get to your folder and assign the project folder to it. So if I select it, you will be seeing the project appearing on your project manager. Then you will be able to run the scene with the assets inside, and you will be able to see that you will be able to move the camera around, maybe to start looking at some of these systems that manages the animation for the characters, or you can go around a little bit better, and you can start, which is really important to do for the sake of the demo. You can activate and deactivate the GI to see the difference, the big difference that it makes in an environment like that. And also, yeah, you can activate the probes, so you will see how they are distributed inside the environment and how they look only for the active geometry, which makes the feature very well optimized, especially for mobile. Then feel free to take our assets, move them around, test something new, and it's up to you. So this was it. But what is next for O3D, and what comes next for imagination technologies, ray tracing, and you artists and developers out there that want to implement some of this feature? As for O3D, some more amazing ray tracing features are in the process of soon being implemented in the engine. And in terms of imagination technologies, we can't wait to eventually collaborate and making new demonstrations, new presentations like this, in order to help you understand and how to implement and understand the feature themselves. Also, you need to be aware that amazing new devices are going to be released soon using imagination ray tracing enabled processor with ray tracing and BVH processing and coherency sorting to allow you to have these features working also on mobile. So what I like to say every time is that what awaits for us is not only a bright future, but a ray-traced future. So that was it. Thank you so much for your attention, guys. I hope I've been clear enough in explaining what we do at Imagination, what is possible to achieve using O3DE, and where we artists, engineers, and developers can go from now on. So again, I'm Alekos Caporali, graphics technical artist at Imagination Technologies, and I hope you liked my presentation.
An online question. Do you recommend high or low poly count in objects?
So for the sake of, it depends. So if you're implementing RTGI for mobile, especially, you will need to go low poly because ray tracing features depends on how many polygons you have in the assets. Obviously, you need to be smart about baking your maps, so you will need to create low poly assets. It's really up to you if it's hero assets, as we call it. You can even go for something like 100,000 polys, and it will still be fine. But for the sake of an environment, it's good practice to actually have low poly assets and to bake your maps onto the high poly maps.
Do you plan to have a level of detail support? Because at the moment, testing 1, 2, 3. Do you plan to have a level of detail support for the probes? Because at the moment, I think if you attach them to an object and you move very far away, do they get deactivated eventually, or do you scale them down, or?
That's a very good question. So unfortunately, I'm not part of the development of the feature. So we are the guys that implemented some of them and started discovering, maybe giving feedback to the developers. But for sure, I will make sure to ask that to the developers and get back with an answer for you. So yeah, it's a very interesting question. It's something that I'm interested in. So you can reach me after the presentation and let's just discuss it. Thank you. Any other questions?
Okay. So for increasing the fidelity of the global illumination in a performant way, do you prefer to increase the density of like a static probe or attach more probes to meshes like you showed? You showed attaching a probe grid to the sphere itself to increase the precision?
So, okay, that's a very nice question. The subsystems, the GI subsystems that I created was to allow the objects to move a little bit better inside the cage of probes that I created, so inside the grid of probes. In general, if you want to, if your scene is quite big, you will just need a big system, and you can even increase the number of probes. The problem is when you move like objects very slowly inside the probes, between the probes. So the feature, in the moment that it detects that the object is between one and the other probes, it kind of switches suddenly, so you can see the artifact. Instead of increasing the probes like to an immense value, you can just create subsystem and maybe managing the ambient multiplier a little bit better to make them merge with the system, which makes the feature maybe a little bit better optimized if you want to have objects moving around. But I hope I answered your question somehow. Yeah. Thank you for that. Yep.
I have another one.
Sure.
So with the activation of the probes, we saw in the video that probes mostly cling to geometry. So,
yep.
So these parts are covered. But for GI, the things that you want to sample are actually the changes in lighting, and they might happen in midair somewhere. So it might be only later that a character moves by into an empty area. Do the probes follow the characters around, or do they rotate with it?
It's my bad that I didn't show that in the demonstration, but yes, they do. So if you have objects moving in the scene and you activate the probe grid, and this is really up to you. It's really simple to implement the feature, and also by downloading the gem if you want to. You will be able to see that if you move, you activate the probe grid and the visualization of the probes. If you have objects moving inside the scene, you will be seeing the probes activating and deactivating in real time. And between them, in terms of like transmission of the informations between probes where there is nothing, as you were noticing. Again, I'm not one of the developers, but I think they just communicate by near probes, by the nearer probe, and they distribute the informations by distance. Unfortunately, I'm not one of the developers. I will get back to you with a better answer just later on.
Maybe a final one.
Yeah, go for it. Thank you.
When it comes to artifacts, so one of the things that you showed was attaching like a probe grid to, for instance, a moving object.
Yeah.
So if you move it around and probes get stuck in geometry, they get deactivated, I assume. So if for instance, like you have the ball and there's a bunch of probes around it and you move it close to the wall, then some of the probes will just move into the wall, right? And they will just sample nothing because they're inside geometry.
Yeah.
Do you tend to see like a lot of these artifacts where you see blotches or black spots appearing? Or, because this was a problem with the NVIDIA RTX prototype that is in O3D.
Very good question. Me personally, I made some different implementation of the RTGI system from the very first moment where it was implemented in O3D up to very recently with the new version. And I should say that with subsystems, especially if you manage them well, especially the ambient multiplier to be maybe something like 0.8, so it doesn't really show up overlaying to the other GI system, I cannot see probes creating artifacts when they go inside the walls. There is also another small feature in the GIC, in the diffuse probe grid component, which is called scrolling. So I think that if you activate that, you will see the probes adapting just in a little bit different way, which I'm not sure how it works properly for subsystems, but it's up to your experimentations, guys. Feel free to just get there and try to implement. But really, for me, it never created any sort of artifacts just by moving probes inside the wall. Thanks. No, and thank you so much for your questions, guys.
Hello, hi. My name is Chen. I'm from Oppo. I have a few questions about this system. So first is that, so I see in the demo, the density of the grid is basically uniformly distributed in the box created, right? What if my scene is kind of my geometry is non-uniformly distributed? I have some area that has really dense, small geometries. Then what is the best way to deal with this kind of situation? Do I have to use a very dense grid to handle that case?
I wouldn't say so. I would say that you can make different GI systems to work together in the same scene. So you may want to have like a general system for the entire environment, but also it depends if the asset that you're concentrating on is a hero asset. So if you have a camera moving in your video game, or if you want to concentrate moving next to an asset, or to see a very specific light diffusion, you can create a subsystem for that and implement it inside a bigger system, or even have it separated and merge it together with the rest of the environment lighting. It will work quite fine. But what I suggest to do is, if you have something that is specifically very more dense than the rest of the environment, create a subsystem. Yep.
Thank you. So a second question is also kind of related to that. Like the overall performance of the system, is that linear to the number of probes enabled, or
yes,
the number of probes of the whole? It's number of probes enabled.
It's the enabled probes. So okay, you will have depending on how many probes you have active in the scene, and they update every time something moves or changes inside the scene. You will have a certain number of rays. For example, I went for 144 for each probe. Yep.
Thank you. What about light sources? If I have many light sources in the scene, would that?
You can do that. You can do that, especially like in the final part when I implemented the small Vespa and the other car. I was activating. I still had the point light, but I also had the directional light and the IBL lighting. They were all being taken into account for the computation of the GI.
Thank you. That's all my questions.
Perfect. Thank you so much.
Hi, I'm Hong Yu from Oppo. My question is, your demo seems showing all similar material. I wonder, like, what kind of a material you actually support, and which material type you don't support.
Can you repeat the question, because it's kind of...
Like, I wonder, like, if you support more complex material type, like a translucent and multi-layer material.
Yeah,
What's the current limitation?
Okay. For the material themselves, or for the GI implementation, do you mean?
For the GI implementation.
GI implementation, there are materials obviously that allows you to implement transparency or partial transparency. So you will see the alpha settings in the material settings, depending on what kind of material you select. But other than that, GI works with the irradiance value. So the irradiance value for now is something that you set by a specific using a specific color for the specific material. So it's independent from the rest of the maps that are assigned to the material itself. It can be detected from the main color of the texture, so it can be like a blend or a picked color from the texture, or you can select it manually. But it has nothing to do with like transparency of the object or transparency of the maps that you have in the scene. You will need to set it manually.
Okay, so basically you are saying like we can apply different illumination models, right? Besides the classic PBR you choose.
Can you repeat that again? Because no, actually there are different PBR materials, but they all have the same kind of implementation for irradiance. So they all work the same way in terms of how they use the global illumination irradiance.
So I mean, like for example, like if we try to do a subsurface scattering model, we can actually do it using the current GI implementation, right?
Yes.
Okay.
And by the way, thank you so much for your questions. They were really good. Any other question? Doesn't look like we have any more. Thank you so much to everyone for being here. And yeah, I hope you enjoyed it. Yeah. You want to? I just disconnected.
Okay. Hello, everyone. So we have a little bit more time, and I wanted to open up a discussion on a completely separate topic. But we wanted to talk a little bit about the Linux Foundation mobile working group. So my name is Omar Zodi. I'm a technical ecosystem manager at Imagination Technologies. We have our friends here from Oppo and Huawei. We kind of just want to talk a little bit about the mobile working group and just kind of open it up to discussion and get a little bit of opinions from everybody. So Imagination is really keen to kind of get involved and push for the working group because it's important to kind of get an idea of what kind of features developers are interested in, what kind of features we want to push for, and kind of avoid fragmenting the open source project and getting kind of lost and lose direction and vision of what's happening. So we got here Huawei and Oppo that would love to also speak up, if you guys want to join me. And yeah, and we're going to open up to discussion and kind of get your opinions on the matter.
Since we didn't get a lot of time to prepare, so this will be like a semi-informal kind of style discussion for the mobile group. And the founding member, so far, we have like Oppo, Huawei, and Imagination. To start this conversation, we'd like to invite Tobias and Omar to first introduce themselves and why they joined O3DE.
Hi, my name is Tob. One or the other might have seen me on Discord. I work for Huawei. We have joined, I believe it was pretty much about a year ago, and I am the TAC and TSC for the O3D Foundation. And I lead a small group of researchers in Dublin that are interested in human rendering and global illumination. But obviously, as a representative of Huawei, I'm standing also here for the company, and we're kind of interested in mobile technology. And to be honest, the O3D engine right now is not in the greatest of shapes when it comes to mobile deployment, so this is a good chance to do something about this.
Yeah, and so I just wanted to reiterate what I mentioned earlier. Imagination is keen on joining and to have joined the mobile working group. Again, it's important to have a good grasp of what kind of technology we want to see out there, for especially what developers want to use, and what's important for gamers to see in their games and their projects. Having this kind of group, it gives you the opportunity to drive it in the right direction and just not get lost in all the kind of different technologies and new ideas that come up all the time. So we're really keen to get this working group up and running, to get more companies and more developers to join and kind of join the discussion and just really push forward with the technology in the right direction for everybody. Cool.
Hi, thank you. So since I have some slides to show, I can briefly go through them before the discussion. And here from Oppo, I have my name is Hongyu San. I also have a Chen Liu there, joined the O3DE. We both came from Computing and Graphics Research Institute from Oppo. Our team located in Seattle. And I'm the head of the team working on graphics for many years. And Chen also is a expert working in graphics for 20 years. And we both previously we both came from Huawei. Yeah. Oppo is a mobile company established in 2004. We currently rank number 4 globally in smartphone market share. So this is about our team. So we're working on a lot of things related to graphics, algorithm, game engine, system graphics, talking about launcher, UI, all this Android graphics stack, GPU, AI stuff, and the rendering pipeline. So the reason why we Oppo need to join O3DE. So what we can contribute to O3D engine. First, talking about ray tracing, we share the same interest as Imagination. One of the reasons we joined O3D is we had a conversation back in GDC with Imagination. They are saying if you want to do this mobile ray tracing, you better to join us in O3D effort. So we have a lot of things done already on O3D. So that's one of the reasons we joined. The other reason, mobile GPU have a lot of features these days, including VRIs and retracing hardware acceleration. And you have to specifically adapt to the mobile GPU API in order to use them. And also on mobile retracing, since it's the very beginning, we don't have a lot of tool chain. We don't have a good enough benchmark. That's how we can build together. And for the game engine, currently, besides the commercial engines, for the open source engines, we don't see a mobile-friendly game developing ecosystem, including O3DE, which means your IDE, your build pipeline, your test pipeline, your deployment pipeline need to be really friendly with mobile developers. Currently, it's not the case. Too many setups, too many interactive steps, and if you compare with the commercial game engines, I won't name them, but you can tell the experience is totally different. They have like a one-click deployment and build test functionality, but for O3DE, it's taking too much time. Like for individual, like non-professional users or non-developers, it's really hard to configure and try this. Also, we have other game features. For example, like ADP, like someone from the discussion thread mentioned, what is ADP? ADP is adaptive performance. It's actually promoted by Unity, Google, and ARM these days, which means allows mobile hardware platform to communicate with your game engine. Like if it's overheating, or there's other like throttling like a situation, we can reduce some like details of the rendering. Also, the last thing, perf tuning and profiling toolset. That's quite important for mobile developers as well. If you don't tune the performance, you cannot play on your phone. So what do we bring to O3DE? So first, our company have a really deep understanding of mobile gaming platforms, and we understand the mobile users, what their need and what's their preference. We can bring all this knowledge to O3D society. We can push forward for mobile technology involvement in the industry, drive the best practice on mobile. Also, we can also speed up the O3D adoption to the mobile game developers. So that's a benefits the O3D. So that's my contact and Chen's contact. We have like a discussion thread online here, discussion 46. And I took some screenshots for the mobile device working group. Maybe like a majority of the people didn't get a chance to take a look. Here is the overview. Basically, the most challenging question is how do you define mobile? Because these days, everything is mobile. Like there's some like very blurry boundary between mobile and non-mobile. For example, people discussing like how about like AR VR device? Does it count as a mobile or not? Because if you consider like HTC Vive, that's basically tensored to the PC environment. And if you're talking about Oculus Quest, that's a pure all-in-one mobile platform. That's why we define mobile like in this way. First, it should be ARM-based. It's not necessarily battery-powered, but it has to be ARM-based. And we need to utilize the mobile GPU features. And it should be on mobile operating system. It should be a mobile-only API. If we want to support OpenGL ES, that's a mobile-only API. And we need to have like a mobile benchmarking on some new applications. So the goals is kind of simple. Good runtime experience of O3DE on mobile targets. In a later discussion, we'll also add another line for the goals. It's a good mobile developer experience. So that's the scope and what's actually in scope and what's out of scope. First, we need to make sure the engine have a really good mobile architecture compatibilities on ARM. ARM is actually really fragmented ecosystem. It's really hard to actually adapt even to ARM ecosystem. For example, there's so many different chipset manufacturers. They define their own stuff. And I think if you're familiar with this environment, you know how hard that will be. Qualcomm, MediaTek, and Samsung, and Huawei, they have even Google, they have their own chipset, and Apple. So each of this manufacturer also have a different tiers of SoC, system on chip. They are high-end flagship. They have a mid-end, they have a low-end. So it's only supporting the compatibility that will really like a time and human source consuming. And we have a mobile resource management. That's a huge different from PC environment. PC, you don't care about how much power you consume, how many watts, right? How many heat it generates. But on mobile, it's quite important. If it's overheating, you basically the hardware platform will throttle you from consuming more, and your game performance will be really terrible. And for the CPU cores, that's very difficult to tune as well, because these days ARM, they propose a really complex CPU architecture. They used to have a big and little cores, right? They have 4 big cores, 4 little cores, but now they have 1 super core, 3 big cores, and 4 little cores. And when to assign which thread to which core, that's also like very challenging. If you don't assign to the right core, you, for example, you assign a really high workload thread to a little core, your game performance you lose a lot of frame rate. Yeah. OS compatibilities, we have that's another headache on mobile. We have so many different Android versions to support. Like people read article about it, Google Android doesn't have a lot of power to migrate their user to the latest Android version, which means if you deploy your mobile game, you need to support a lot of legacy Android versions. And also, there's other operating system than Android. For example, Huawei, they have their own operating system. TBR, TBDR, that's a hardware GPU features. Unique feature support for sure, API. And this is something still in debate, like should we support OpenGL ES or not? Because currently O3DE is pure Vulkan-based, and I think there is some support. Someone strongly support OpenGL ES in the discussion thread, saying we have definitely to support OpenGL ES on O3DE on mobile, for sure. But the question is that's basically you need to rewrite a lot of things and very resource intensive. And we also need a really lightweight rendering pipeline on mobile. We need to support ray tracing. We need a hybrid pipeline as well. And also we need a lightweight asset pipeline. So we couldn't deploy all this PC or console quality textures and all the assets to your mobile phone. That's a lot of work. Perf tuning, popular game engine features, that's it, yeah. Autoscope for now, but this is still in discussion, like should we support cloud gaming, should we support all this even lighter devices like watch, wearables. Currently, as far as I know, there's not a lot of games on your watch, yeah. So, that's the current status. Also, the last page of the slides. Current status, we have like a Huawei, Imagination, Oppo, as a founding member for now for this group. And if any company interested in this, I noticed there's someone wearing Houdini shirt. And if you are interested in joining us, you can let us know. That's my email, because currently, we don't have an official secretary of the work group. We're going to find one person which is more proper for this. And also the group is not officially announced. The announcement will be tomorrow. Yeah, we're waiting for the official announcement. We'll have some like open discussions like for the suggestion to our charter and scope. And do you have anything to add, Tobias and Omer?
So I'm not sure I got everything. Did you mention testing? Testing, yes, testing frameworks, anything related to testing. Because what is happening right now, at least at Huawei, is we have a bunch of engine developers and people who write prototypes, and they keep breaking things left and right. And at the moment, I'm not sure. I mean, we can have a sort of like testing framework internally. That is not a problem. But for the open source project itself, it should be just as it should be for a game engine user. It should be easy to set up a project and deploy it on mobile. It should be equally easy for a game engine developer that wants to contribute to the open source project to run tests. And right now there are 0 tests, so things keep breaking left and right. I think that's a big topic in on itself.
Sure. Can I say something about the test? I think testing is kind of especially tricky for the mobile developers because the development ecosystem is, like Hongyu mentioned, is fragmented. There are like maybe over 100 of different devices on the market, right? When you develop, it's impossible for any developer to test their code on all the different devices. So some engine, like Unity, they provide a really mature testing system for developers to do a one-button click and testing on all different platforms provided by Unity's infrastructure. That is a really, really strong feature that I think all the mobile developers likes. So if O3DE can provide something like that, I think this will like basically a good feature that will absorb like the interest of mobile developers. Yeah.
Yeah, talking about that, that's I think that's one hard issue like open source project is to handle. For example, like Unity test cloud, they have like support 1,000 phones, but cloud-based testing is very pricey, like because you need to maintain the cloud services, right? As an open source collaboration, I don't think the organization has too much fund to support really heavy like cloud testing environment. So how to solve that? That probably require a longer discussion. Yeah.
That's it.
Yeah, so in that case, we can continue to the next question. Like since we mentioned in the scope and charter, we have so many things to do. Like what do you think the high priority work in this mobile group? And what's the big milestones? Omer, if you want to start.
So I think as a high priority going forward, especially with O3DE, is to start this discussion is part of it. Start defining what the main parts of the mobile render that we need out of O3DE are. I think O3DE is at a good point when it works to desktop. I think we should now start discussing in which direction we want to drive it when it comes to mobile and prioritize the features that are important right now. I think, for example, the VRS is an important feature that we want to take a look at and potentially prioritize. I think it's also important to understand how much time is going to take for these features to become a reality. And you mentioned earlier about GLES or Vulkan. I think it's important, for example, to prioritize Vulkan because that's the future going forward, and potentially include support for OpenGLES as we progress with the work we're doing. But I think it's important to be forward-looking when we think of the kind of work we want to implement. And part of that is to have a discussion and collaborate with as many developers and companies out there to understand what the real needs of the developers and what players are looking for when it comes to gaming, or in any other industry, be it cinema or automotive or anything else, what those customers are actually looking for, and not necessarily just prioritize things for the sake of the technology itself, but to make decisions that are useful to everybody that benefits from these kind of projects. Tobias?
Yeah, I think to make it practical, I guess another thing that we should consider very early on is to get the build tools up and ready as soon as possible, because as soon as we have more users, they'll start to complain, right? That's when we get the bugs and tickets and issues and discussions around what is missing, what do we actually need. So and at the moment I just don't see that. It's like people unpack O3D, the O3D engine, and they have no idea how to even get started on a mobile title. So as soon as we have that, we get sort of like a second lane where people start adding sort of our requirements other than the ones that we are coming up with right now. That's I think a big thing we should focus on also.
Yeah, talking about that, I think we had some internal discussion, like that's very like urgent issue if you want to start a mobile work group, is to fix all the build and development environment. The currently single empty project taking multiple gigabytes of storage. I heard a ridiculous number, it's 70 gigabytes if you want to start an Android project. And if you build an empty game, APK, AB, this kind of package, the package takes 2 gigabytes with nothing. Like that's a new project, new game, Android game. It contains so many like contains 1 gigabyte of dynamic libraries, SOs, and many of these SOs taking like 100 megabyte itself. And that's something we need to first to handle with. And there is many like SOs. I don't think we actually need it for mobile environment. So we need to first to look into all the entire build pipeline, how many things we can shrink down, at least make it manageable, like under 100 megabyte for the empty project. Yeah. Since we only have like 2 minutes, we have like the last question. I think we can delay this question discussion to our dinner time, round table style. Yeah. That's I think that's all for the discussion. Yeah. Thank you.
Thanks everybody for attending the workshop and this open discussion. Yeah, enjoy the rest of O3D Con. Thank you.